Hello everyone, welcome to the last lecture in the series of Deep Learning for Control. In this lecture, we will be discussing a few recent approaches in the direction of deep learning based control and their applications as well. Here is the overview of this lecture. We will start with a brief discussion of some of the recent approaches and also discuss the applications of deep learning in control. Hybrid models are one of the recent trends in the area of deep learning, especially in control. These hybrid models combines first principle models, which are based on physics-based equations, and also the data-driven models, which uses deep learning models. One of the main examples is the physics-informed neural network, or PINN, in which we include a physics-based term in the cost function as a regularization term. And this physics-based term is defined using the first principle equations. And that term will improve the accuracy of the trained model. And the other direction is the reinforcement learning, which combines deep learning with control. And deep reinforcement learning is one of the active research area. It uses deep learning models for either approximating the cost function or the policy function, and which is used for decision making. And another direction is the transformer based control. For example, transformer based MPC is proposed in this paper. It uses the transformer model, which can capture the dynamic behavior in the system, and such models can be effectively used for solving control problems. Other recent approaches include transfer learning, graph neural network, etc., which also has potential applications in control problems. Next, we move on to some of the applications of deep learning based control algorithms. Deep learning based control and reinforcement learning are commonly used for controlling robots. These are actually complex mechanical systems for which a first principle model may not be able to capture the entire dynamic behavior. And the first principle model may not be accurate and fast enough to solve the problem. So therefore, RL algorithm or deep learning based control schemes are used for controlling robots. And another direction is process industries like chemical plants or refineries. There, in many of the cases, first principle models will not be available. Even though deep learning based control schemes are not implemented in currently, but in future it is going to be one of the application area. And another direction is network systems, where we can apply deep learning based control algorithms for controlling systems such as power grid, cyber physical systems, etc. These are the major references for this lecture series. Finally, I would like to thank all my collaborators with whom I had worked on various problems in deep learning and its applications in control. Also the automation lab in IIT Bombay, and the PDASA group in University of Alberta. That leads us to the end of this lecture and also this lecture series. In case of any suggestions or feedback, feel free to contact me in this mail ID. Thank you all for watching.